I always make the wrong choice. Okay. Okay, so, what we've done in preceding video, because I accidentally stopped the thing. But what we've done is we've set up a general expression for the volume beneath a surface defined by a function f of x, y above the 8 by 8 square with the lower corner at the origin. Okay? I could do this for any rectangle anywhere in the plane. I just changed my numbers a little bit. The exact volume is a limit as your delta xi's all go to zero and delta yj's all go to zero. Now, again, there's some technicalities around this. I prefer to talk about the mesh of the partition to be a little more rigorous, but we're going to live with it the way it is. Okay, so we have this limit of this sum. And this equals a double integral of f of xy dx dy. Okay, what are the limits on the integral? What do you think the limits ought to be? What I mean by this is we integrate f of xy with respect to x, and then whatever we get from that, we integrate with respect to y. Okay. And I kind of got I knew I was going to do something boneheaded. Kind of got my subscripts, my delta x's and delta y's, kind of in the wrong order. But let's not worry about that yet. I think you'll understand when you see it. I don't think it'll cause any confusion. Anyhow, the point is that my x's go from 0 to 8 because I partition the interval from 0 to 8 for x. And my y's also go, in this case, from 0 to 8. Now, if I had a different rectangle, well, it would still be easy. I just have to know what x interval and what y interval I need to partition, right? So that's easy enough. In other words, if I have y going from A to B, x going from C to D, the partition would be C equals x1 less than x1 less than dot 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 less than xn equals D. And A equals y naught less than y1 less than yn equals D. So my integral would end up being, let's do the y interval inside this time. We could write it as the integral from A to B of f of xy dy. And then for x from C to D. That's it. That's how simple it is on a rectangle. It gets more complicated because we usually aren't doing this on a rectangle. We start with rectangles. Okay, get those under our belt, and then we move on to, like, for example, I did a triangle. That just, starts at the lower corner and up the upper corner, so I just carved the upper corner. Then my Y interval is gonna depend on my X interval, okay? Gonna have less of a Y interval toward the left and more of a Y interval toward the right, and we have to deal with that. So, just kind of get emotionally prepared for that and handle it. Okay, so there we have it. Now, let's go ahead and figure out the area of our, or the volume of our original figure. Okay, well, I can't go back to that, we can. I'll get there. Get the back here again. Okay. That's not it. I think our function is f of x, y. Was this. Okay. So what's the volume? So let's do that. Now, you do the inner integral first. You got the dy integral. I've chosen to write that one first here. It doesn't really matter in this case, but in some cases it does. In most cases it does. Right now, we don't worry about it. So what's this integral with respect to y? What are you going to do to integrate this with respect to y? You're going to treat x like a constant. Just, something to do with partial derivatives. So go ahead and get your integral and see if we get something reasonable for the volume. Oh, crap. Okay, well, I did this and I made a careless error and caught it by the fact that this is way too big. I'm guessing that this thing is about 8 by 8 by roughly 12 to 15. Okay, because the slope isn't that big. And when you do that, you find somewhere around 800, give or take a little bit. Like 100. Okay, so when I integrated y squared, I should have gotten y cubed over 3, shouldn't I? Oh, wait a minute. No, when I integrated 1/2 y, sorry. I should have gotten 1/4 y squared. So this should have been y squared over 4, which would make this 16, which would make this 16x, which would make this 128. And now things are a little more reasonable because this is pretty close to 800. And this is a negative. It's not that much smaller in magnitude than this. So we're getting something around 800. Okay. A little more than 800. No, kind of expected. Okay. So there it is. Now, that's fine. Let's see what happens if you integrate this in the other order. Now we could as easily have written this integral. This way. Integrate with respect to x first. Well, not going to spend time on it. You'll have a fair amount of time, but not that much. we get the same result. Okay. So we can reverse the order of integration provided the region that we're looking at here is 0 less or equal to x less or equal to 8, 0 less or equal to y less or equal to 8. And that's the region of this interval. And that's the same as the region 0 less or equal to y less or equal to 8, 0 less or equal to x less or equal to 8. You need that line there. Okay. They're the same region. Each is the 8 by 8 square. Okay. Okay. So I'm just looking down through the problem you're going to do. And you can always just interchange the limits on your integral. And interchange x and y and interchange the x limits with the y limits, okay? You can always do that as long as the region's the same both ways. Now, usually it won't be. So when you change the order of integration, you got to do a little bit of work, but for rectangles, you're okay. It doesn't matter for any rectangle. It doesn't matter which order x and y inequalities are written. That should be clear. But read your book and try to understand things deeply because we're into a chapter that gives people trouble. Okay. The better you understand this section, the better you're going to be able to build on it in the next section and so forth. And you need to understand the notation here. Okay. You have problems where you're given an integral and it asks you to evaluate it by choosing the order of integration. And I should say this on camera. No, I'm still on camera. So, I mean, at least we're recording. Okay. You should write those integrals down both ways. Okay. And then decide which way is easier. And if you're not sure, go ahead and integrate both of them. You'll find one of them is an easier integral. You'll see why. And then you'll begin to develop a feel for which order you want to use to make the integration as simple as possible to avoid mistakes. Okay, now looking a little further down, you have several problems where you, okay, now, big deal. What's the average value of this function? Okay, now I can work this out. Subtract 256 from that, you get 2180. 2180 divided by 3 still isn't even. It's 726. And oh, come on, man. My brain just stops at that point. Trying to get the fraction, I wanted to say 2/3. But I don't remember what I said before, so it doesn't matter. This and this come out around 700. So this comes out around 800. Okay, so well, it isn't really 800. But pretend it is. I was saying, what's the average value of our function, this function, on our 8 by 8 square? So how do you get the average value? Hang on. Got a quick answer here, and I'll bet it's right, but let's see. Okay, what I got was a very good answer. Just divide the 800 by the area of the base, which is 64. Okay, it's a little over 800, but still, you're gonna get 570 maybe, something like that. No, 57. Okay. You wouldn't get that much. 64 into 800 is only like 13. Okay, and that makes more sense. Okay, the average height's about 13. Well, the point we started with was at a height of 12, and you got a plane that was kind of gone up away from that point, right? Think about it, go back and look at it and convince yourself, because you get more insight into what's going on. So you divide the volume by the area of the base and you get the average altitude. I mean, fundamental thing in geometry, if anybody ever taught geometry in our public schools, is that the volume of a prism, okay, is altitude times area of base. Volume of a right cylinder, okay, area of base times height. It's area of base times height. So the height is the volume divided by the area of the base. So it makes sense that the average height of something that isn't flat on top should be equal to the volume divided by the area of the base. Okay, so then you can think of, you take this thing that maybe has altitudes that go from 10 to 15 over here, okay? Reasonably, the average altitude might be about 13. Okay. It's reasonable. You can figure out more about it than that, but okay. So this whole idea about the average value of functions is a big deal. Use it all the time. Yeah. I gotta urge you, when you do your homework, keep formulas out from in front of you. Don't sit there with a bunch of formulas and plug numbers into the formulas and think that you're learning the math. That's not math at all. That's something you teach a fifth grader to do. Okay? Understand the math. And if you need to look at a formula, fine, but put the things away. You see the next problem, and now you try to retrieve stuff out of your memory, which is what puts it into your memory. Okay? And you're not always going to be successful. On the early problems, you might not be successful that often. But as you go on, you should get better and better at recalling what you need and the concepts that you need in order to solve these problems. Because I didn't see evidence that people were really doing that on the first test. Okay. So it's the way you approach the homework. It's not just about getting the points. And I know you know this. It's not just about getting the points. It's about learning what's going on and being able to solve similar problems later when you see them, so that you really understand the concepts and you bring all these ideas together into a nice whole when you prepare for an exam. Okay. So I don't know how individually that works. I'm just using the whole thing of formulas in front of you as an example. And I'm sure not everybody is doing that, but don't bypass the need to understand and put things together, because that's what you learn. That's what we learn. Okay. So get yourself a good start on this chapter and really think about what these things mean. Okay. 2 minutes early. I don't think anything more to say. I could say a lot, but